Work. What is work? So, work is when you apply force, means try to change the momentum of this object force. And suppose it displaces the chair at T1 at T2. So, the displacement, that is this, let's take S. So, the work done is defined as work is equal to F dot S. These are vector quantities, but these are scalar. So we don't need to write these vector because there is no vector involved in the working of work. So simply work is equal to Fs cos theta. What this theta means, the direction of this force is in this direction. That's force, and displacement also happens in this direction. So theta is 0 degree in this case, and cos 0 degree is 1. So works done comes out to be Fs cos 1 means simply this. This is the simplest work done formula whenever direction of force and displacement is in the same direction. Then this is the simple formula you can use. Just multiply the magnitude of force and displacement and you would get the work done. But what happens if this angle is not uh, 0 or for any other angle? We can use this formula. This is commonly teach in 9th classes, and this is full-fledged class 11th. You have to know this. So let me tell you something about when this angle is not 90 degree. For that I need to rub this off. Let's take. So suppose an object, this, okay, and force is applied as with this horizontal, this vector has angle theta. Suppose this body is only allowed to move in over this plane in which it is placed. So what happens is it only move in any direction on the plane. So the direction of motion would be in this direction. Suppose this is S. So the direction of S is this. So in the direction of S, the contribution of F can be found through by taking trigonometrical ratios, and this is force vertical component and this is force horizontal component. So only the horizontal component of this force can participate to doing the work done. So that's why whenever there is an angle theta, we instead of using F, we use F cos theta, because this is the contribution of F in the direction of S only. And what about F sine theta, which is this vertical component? This balances the weight of the body. So this is the free body diagram. Work done. That's why work done. Sorry, this is weight. Work done is Fs cos theta. Let me give you how work is positive and negative. So let's talk about cos theta. So for cos theta, at theta equals to 0 degree, the cos theta equals to, yeah, let me write it, 0 degree. Then cos theta is, value of cos theta is 1. And let me remind you the class 10 at 30 degree, its value becomes under root 3 by 2. And 45, it becomes 1 by under root 2. And at 60 degree, it becomes 1 by 2. And 90 degree, it becomes 0. So how this cos behave? So if these values are plotted, x, suppose this is the different values of theta, and this is +1, and this is -1. I think you can see. So the from 0 to 90 degree, suppose 90 is here, it went from 1 to 0 to 1 to 0. If I keep writing these values till 160 degree, you can see that it goes like that and that till 360 degree. So that's how cos function look like. So in this region from 90 to this value, what is this value? So this is 90, this is 180, and this is 270. So from 90 degree to 270 degree, if you want to express in this radian, that is pi by 2 to minus pi by 2. So this in this region cos is negative. So whenever situation comes when value of angle lies between this range, then work done would be negative. The 180 degree comes in this range. So let's see what happens at 180 degree. It's a case in which force is applying in this direction and body is going in that direction. You can say how this can be happen. This I will tell you later. But please, for understand the case of 180 degree, just take this example. So the angle between force and displacement is 180 degree here. So work done cos 180 degree is nothing but negative 1. At cos 0 degree, it is 1 plus 1. So this is, so in this case, work Fs cos 180 degree, this is -1. So work becomes minus Fs. So whenever the angle between displacement and force is 180 degree, then the force is 1. And also in this entire range, that is pi by 2 to minus pi by 2. So this is the concept of negative work done. If you understand this, you already understand positive work done. The other range minus this. In that range, value of cos is positive, therefore the work done in that range is positive. I'm not just telling you what is the where negative or positive, I'm just telling you how. So how the positive and negative work done is defined.